KINS 260. I know we're not having class on Wednesday, January 30th because of extreme cold temperatures, but I don't really want to lose traction in class. So I want to do a quick review over the things we talked about on Monday, and then I'm going to cover new material. It's just a tiny bit of new material, but we didn't get to it on Monday. This way we're covering it in video. And then Friday when we meet again, we can just keep moving forward. Okay, so a couple of things to review. I wrote out all those key terms on the board, right? So I filled the board with all these key vocabulary words that I want you to be thinking about. Make an index card, use Quizlet, whatever it is for you, figure it out, right? So that you can start to learn these key terms. Okay, so I'm gonna go over a couple of these. Epidemiology is population medicine. So I said that I kind of think of it as putting math to negative health outcomes. So it's just applying math to understand how diseases move through populations. Epidemiologists are the people who do that work. They collect information about disease and they kind of ask the who, what, where, why, and how of infectious diseases or of accidents, things like that. And remember, John Snow is our fantastic example that we've talked about a lot about an epidemiologist. He went around and just said, who is sick? Where did you go? Do you go to school somewhere? Do you work somewhere? What did you eat? He asked these questions and figured out taking the handle off the pump would solve the problem. Okay, and then there were these four terms and they sound kind of similar. Epidemic, which is an unexpectedly large number of cases. Endemic, a disease that happens as a matter of course. And pandemic, there's three outlined. Pandemic, an outbreak over a wide geographic area. So epidemic, oh my gosh, so many. Who knew? What's going on? Endemic, it happens. It's like malaria. It just happens. We expect it to happen. Pandemic, it is over a wide geographic area. Typically, that's geopolitical boundaries. Not always. We talked about Zika. We talked about Ebola, swine flu, things like that. H1N1, those were things that we considered or were at risk of becoming a pandemic. Okay, we talked about the history like a touch. We've gone over that quite a bit, but I just did remind you that both of these statements are true. Yes, there is evidence of community health activities dating back to 2,000 years BCE. True. And also true, it's only in the last 100 years that we've taken aggressive, intentional, thoughtful action to promote community health. Both those things are true. Then we talked about rates, and a rate allows for comparison of outbreaks at different times and places. So it just allows you to compare. I can compare the cholera outbreak in London in 1845. I can compare that to the measles outbreak now or something if I wanted to. It allows me to compare. Cases, it's kind of like a count, like a case count. A case is a person who has the issue, a person who is sick, or a person who broke their leg, whatever it is. It's the people who are afflicted. We talked about different kinds of rates that we collect quite often. Birth rate, death rate. We're really good at those. Thank you, Chautauqua Report 1850, Modern Era Public Health. And the population at risk. And the example in class we had there was, we're talking about like prostate cancer, and there were 6.7 million people in Indiana. Are we all at risk of prostate cancer? We are not, because we're not all men, right? So it's really important that you think about the population at risk in your denominator, and I drew that out on the board for you. Incidence and prevalence, super important. These had asterisks. Remember that one. Incidence rate, the number of new health-related events or cases of a disease divided by the population at risk. We use incidence to study acute conditions. Acute is short term, so like flu, bronchitis, pink eye, strep throat, a cold, food poisoning, things that don't last that long. Incidence is new cases of a disease. It's for acute or short-term diseases. Prevalence, new and old. Such a key part of that definition. New and old cases of a disease in a given period of time divided by the total number in the population. And we use prevalence to study things that are chronic, long-term, last longer than 3 months. These would be heart disease, almost every kind of cancer, diabetes, kidney failure, paralysis, things that last longer than 3 months, right? Okay. And then on page 63 in your book is a chart. It's on the slides too. And remember, it had incidence and prevalence. And I said, I even put a post-it over attack rate. I will not ask you to calculate math. I don't want to grade your math. But it's the incidence and the prevalence I really want you to focus on there. We talked about the interpretation of rates, and we used the examples in your book of Alaska and Florida. So if I showed you only crude death rates between Florida and Alaska, remember, Florida looks really bad. You should never go there, right? But then I control for age. I use an age-adjusted rate. I take into consideration the fact that there's a lot of old people in Florida, right? So I take that into consideration, and then I use an age-adjusted death rate and see that Florida is quite healthy and safe, and that Alaska actually has a much higher mortality rate. And we talked about why that was. Reporting these rates. Remember, I drew on the board. I wish I had a visual. It was those 4 steps in a line, right? The system is the National Electronic Telecommunication System, or NETS. But whenever there's one of those nationally notifiable diseases, and they're in your book too on page like 64, your clinician diagnoses it. Then it goes to your local health department, state health department, and the CDC. Remember that process? And we even like drew a picture over that. Keep that in mind. Okay, then we talked about some standardized measures of health and populations, death statistics. So if we have a lot of people dying or an unexpectedly large number of people dying, there's a problem. It's a pretty reliable measure. And then we talked about life expectancy, and we pulled that chart up that was really small on the board, but it's in your book too. And we looked across the 1980s row, right? We used me as an example and talked about my life expectancy at birth, generally, and then my life expectancy at birth based on gender. You know, I mean, we went on down the road there and talked about the fact that females live longer than males, and that the longer you live, the longer we expect you to keep living. We went through those. And we use those life expectancy measures to calculate the years of potential life loss. And this is really important, right? And I gave you the example. If you had the one life-saving vial of antidote to cure somebody, and you have one neighbor who's 75 and one neighbor who's 1, who gets the vial? It's the 1-year-old, because we will always weigh the life of a young person as counting more than that of an older person. And it's the same idea as the years of potential life lost. So to calculate that, we figure out how long you should have lived, and we subtract the age from which you actually died, and those are your years of potential life lost. I told you don't do the disability adjusted life years, health adjusted. Nobody cares. Too advanced. Secondary data versus primary data, right? We talked about that example in class. If I was going to ask like what make of car, what make or type of car people on campus drive, which is silly, but I collected the data for my own purposes. That's expensive and time consuming, and so we use a lot of secondary data in public health. And the census is a really great source for that for us. They ask all kinds of questions, and they pay for it, and we get to use it. So we use secondary data quite a bit. Talked about the MWR. Then we went on to national health surveys, and there were a couple in particular we kind of focused on. So one was the National Health Interview Survey, where they interview people and ask them questions about their health. So they would say, hey, mister, what is your blood pressure? How much do you weigh? Do you know what your blood sugar is? Tell me what that is. And they ask you these questions, and you self-report it. Yeah, they're asking some questions and getting some information, but it maybe isn't super accurate, right? And then there's the National Health and Nutrition Examination Survey, which has the word exam in the title. And that's where they don't say, do you recall your blood pressure? They say, come on in here and give me your arm, because I'm going to find your blood pressure. I'm actually going to do a clinical exam and collect this data in real time. Remember I said it was like an RV that drives around the country? So one asks questions in the interview process, and one actually weighs you, takes your blood pressure, probably does a blood sugar check, things like that. Just think about the difference there. And then we talked about epidemiological studies and descriptive versus analytic studies. So descriptive studies, think Jon Snow a little bit there, right? So he just walked around and he asked questions. Who is sick? Where are they? He mapped it, remember? Who is sick? Where did you go before you got sick? How long has it been since you got sick? Who else didn't get sick? And he asked a bunch of questions. He basically did a descriptive study. That lets us do a couple things, including develop an epidemic curve, and that tells us how long it takes between exposure and onset of symptoms, which is useful, and it helps us track a disease over a population, which he did. Epidemic curves also tell us one thing, and Jon Snow figured this out too. It tells us if we have a point source epidemic or a continuous source epidemic curve. So a point source, remember Jon Snow took the handle off just one pump, just the one, and he basically ended the cholera outbreak, right? So it was a point source situation. That's not an example. It was a real situation, right? He figured out that if he took the handle off one, maybe it would stop, and it did. All the other pumps kept working. A continuous source epidemic curve is a little harder to address. It's coming from all over the place. It'd be like flu right now. A lot of people have the flu. I don't know where it started. I don't know how we would even figure out where it started right now, right? Because it's coming from all over the place. Very different there. And then we talked about analytic studies where we are testing. We have this idea. We want to test it. We have a hypothesis. We're going to put it in action. We're going to see what happens. So actually, we talked about how Jon Snow went from a descriptive study to an analytic because he had a theory that if he took the handle off that pump, people would stop getting sick. So he took the handle off the pump, and they did. It actually worked. So that was an observational study. So he... No, it was an experimental study. I'm sorry. So he took the handle off the pump and he figured out what happened, right? We talked about the difference there. And then we even talked about in class experimental studies, and I said this half the class gets an intervention that I think will work, and this half the class gets the same looking thing, but it's actually a placebo. It's like a sugar pill. It doesn't do anything for you. And so that's an applied intervention with the placebo in a control group. And that's an experimental design. And then this is the new piece of information that we didn't get to, which is determining causation. This is in your book. There are certain things that we need to do to determine if there's a causal relationship between two events. There are 5 criteria: strength, consistency, specificity, temporality, and biological plausibility. Strength. So let's just think about like drinking Coke and weight gain, Coke or soda or something like that. So in that situation, so if I drink one Coke, if you have a group that only drinks one Coke a week, did they gain much weight? Well, I mean, they might have gained a little bit of weight. Okay, so the next question is, okay, so if they drink 5 Cokes a day or sodas a day, full sugar sodas a day, do they gain more weight? Is there a strength in that relationship? Because Coke, a can of Coke, this is a Diet Coke, so it doesn't count. A can of Coke has probably 120 calories or something in it. 120 calories times 5 a day is 600 extra calories. You will gain a pound in 2 days doing that. So if you did it every day, you're going to gain a lot more weight. Consistency. So this is saying if that group over there drinks 5 Cokes a day and they gain weight, does that group over there, does the same thing happen to them? They added more Coke in their diet and they also gained weight. So it's a consistent outcome. Specificity. Is it something else? Maybe they are also eating McDonald's with their Coke. Is it the Coke or is it the McDonald's? You have to be able to determine the specific cause of their relationship. So is it the Coke? Did something else change? Did they quit going to the gym? Did they break their legs so they can't walk anymore? Something else like that. You have to make sure it's a specific relationship. And temporality is the next one. So does it make sense that you had the exposure, in this case to the Coke, before the weight gain? Or did you gain weight and then start drinking Coke? That wouldn't work, right? You have to have the exposure to the intervention, negative as it is this time, and then the outcome. So you drink Coke and then you gain weight. So that temporal or time-based relationship has to be there. And then biological plausibility. Does it just make sense with what we already know about the human body? Does it just make sense that if you consume an extra 600 calories a day, you'll gain weight? And yes, that does make really good sense with what we already know about the human body. Those are the 5 criteria for causation, for determining causation. You might want to be able to recall those. You might put those, causation criteria on one side of an index card and be able to list those off and have them listed on the other side and test yourself, right? So you may do that as you move forward. Okay, that is chapter 3. I've reviewed the whole thing pretty much now, and I've gone over the one little bit of new information. I hope you watched it. I hope you're staying warm, and I will see you Friday. Thanks.